Hey guys, in this video I'm going to talk you through how to answer every single question which appeared in paper 3 of the Year 6 SATs 2024. Question 1. These shapes have a fraction shaded. Match each shaded fraction of a circle to the same shaded fraction of a rectangle. One has been done for you, so it shows you an example of the half of a circle is matched up to half of a rectangle. It's 2/4, which is equivalent to 1/2. So what I would do for a question like this is I would label my fractions on both sides and then find the equivalent. So this one is 1 shaded out of 4, it's 1/4. Here we've got 2/3, here we've got 1/2, which is already done, and here we have 3/5. And then on the other side I would shade in the fractions as well. So here we have 6 out of 10, here we have 4 out of 6, and here we have 2 out of 8. So this is, we found the fractions that are shaded and now we need to match up. So 1/4 is going to be the same, it's not the same as 6/10 or 4/6, it's the same as 2/8. 2/3 is the same as 4/6. So this is understanding your equivalent fractions. If you don't know how to do a question like this, 3/5 or 6/10, then you need to revise your equivalent fractions. I have plenty of courses on that skill. Question 2. The temperature in a freezer is minus 40 degrees Celsius. The temperature increases by 10 degrees Celsius. What is the new temperature? So we've got an increase and we're using negative numbers. I would use a number line to solve something like this. So I would plot my first number at the beginning. So negative 40 is going to be the smallest number because it's going to increase. If it was decreasing, then the negative 40 would go this end. So negative 40 is going here. I always like to put a 0 on my number line when I'm using negative numbers. So negative 40 is here, 0 is here, over here somewhere, doesn't matter, doesn't need to be to scale. The temperature increases by 10 degrees. That means it's going to get closer to 0. Okay, it's adding 10 and negative 40, add 10 is negative 30. If you're unsure how to calculate with negative numbers, I have lessons on that in my Year 6 number place value course. Question 3. Jack buys milk and orange juice from a shop. We have the milk and orange juice pictured with their amounts labelled underneath. He pays with a £5 note. How much change does Jack get? So this is a simple 2-step problem. There are 2 marks available. We need to first find out how much the milk and orange juice cost by adding them, and then we need to subtract it from £5. So we first need to add up our £1.45 and our £2.40. Now you might be able to do this mentally. If you can, go for it. 5 plus 0 is 5, 4 plus 4 is 8, 1 plus 2 is 3. So we know that he paid £3.85 for the milk and the orange juice. So now we need to do £5, subtract the £3.85, which was the total of the milk and the orange juice. So this bit is a bit where you need to be a bit careful. You can't take 5 away from 0. I see lots of people write 85 as their answer here, but it's not. So we need to make sure that we are subtracting correctly. 10 take away 5 is 5, 9 take away 8 is 1, and 4 take away 3 is 1. So the change that Jack gets is £1.15, and make sure you write it correctly. The pound symbol is there, so it needs to be written in pounds, not pence. If you've converted it to pence at any point, £1, make sure you put your decimal point in, and the 15 pennies. Question 4. The diameter of the moon is 3,476 kilometres. What is this diameter to the nearest 100 kilometres? We might be forgiven for automatically thinking this is a circle question because we've got the word diameter in it, but actually it's to do with rounding. So we're rounding 3,476. I'm just going to write it big, to the nearest 100 kilometres. All we do here is we think about what digits in our 100 column and we look at the digit afterwards it's bigger than 5, so we're going to round this up. So this 4 rounds up to 5, everything else becomes a 0. So to the nearest 100, the answer is 3,500. Question 5, match each of these Roman numerals to the correct number. 1 has been done for you. Now Roman numerals is one of those funny topics. It often has 1 mark in the SATs. Not every year, but most years. I have got some free stuff on Roman numerals on my YouTube channel, and I've also got some stuff in my Year 5 course. So what you need to do here is I would just look at each number and decipher it, then find the answer. So D, X, C, D is 500, X is 10, C is 100. The 10 is before the hundreds, that means 10 subtracted from 100, which is 90. So 590. The D is 500, the L is 50, and then we've got 10 tens. We've got 550 plus 10 plus 10 plus 1, that's 571. And then your M is 1,000, your C is 100, and your X is a 10, so 1,110. Question 6, match each fraction to its equivalent simplified fraction. 1 has been done for you. So usually I'd just say, find your equivalent, your simplest fractions next to these, and then match it up. But in fact, I would actually look quickly, and I can see that 2 of these have got denominators of 5, 1's got a denominator of 4. So if I look at my 3 fractions, I've got a denominator of 20, 15 and 16. I can already see that there's only 1 with a denominator that is in the 4 times table, so those 2 have to match. Now I know that these are both going to get simplified to 5. My 20 to get to 5 is a divide by 4. So 20 divided by 4 is 5, 12 divided by 4 is 3. So I know, and in fact it's probably better if you write the divide by 4 the other side so it doesn't get mixed up with your lines. I know that's going to be 3/5. Just to double check, the 15 needs to divide by 3 to get to 5. 12 divided by 3 is 4. That just makes sure that we've definitely got the right answer. Never just assume there's one missing opportunity, so I'm just going to join them up. Just double check, because that might be how you find out if you've made an error. Question 7, Emma thinks of a number. She says, I multiply by 2, I add 11, I divide by 3, my answer is 9. What number did Emma think of? This is quite a common style of question in the SATs. I would always express this algebraically and then work backwards. So I'm going to put a question mark to represent the number she thought of, because that's what we want to find. She multiplies by 2, she adds 11, and she divides by 3, and she ends up with 9. Now what I'm going to do is then box up these calculations into separate boxes, circles. You don't have to do it like this. And we're going to work backwards. So I'm going to start with my 9. If I work backwards, now I just go backwards this way, but you might want to write it with your 9 to start with. I'm going to just show you how I would do it. So we're going backwards. We want to undo. So to undo the divide by 3, we times by 3. To undo the add 11, we take away 11. And then to undo the times by 2, we divide by 2. And that should get us to our answer. So first of all, we do 9 times 3, that gets us to 27. Then we do take away 11, that gets us to 16. And then we do divide by 2, that gets us to 8. So our answer is 8. Now if you want to, just put it back in and just check. So if you started with 8, if you multiplied by 2, you get to 16. If you added 11, you'd get to 27. And if you divided by 3, you would in fact get the answer of 9. Question 8. Here is a shape. Draw the shape after it is translated 8 units to the right. So we've got our shape. It says use a ruler. Very important to use a ruler, even if you get these points right. If you don't use a ruler, you will not gain the marks. Okay, I'm going to zoom in for this one. Now, if you're very confident with calculating with negative numbers, you can actually just add. But otherwise, I would just suggest manually checking each one to 8 places. So if we look at this point at -3, we would count 1, 2, 3, 4, 5, 6, 7, 8 and plot it in. I'm just going to put a cross. Now you might be able to see that -3 plus 8 is 5. Yes, it gets to 5. -6 plus 8 is 2. but you might have counted 1, 2, 3, 4, 5, 6, 7, 8. Now when we translate, the shape looks exactly the same. It's not like reflecting, it's just literally picking it up and moving it. So you might be able to just do some deductions. So for example, I know this point is one place to the right, and it's 1, 2, 3, 4 places up. So one place to the right, 1, 2, 3, 4 places up. I could also check this point is at -5. -5 plus 8 is 3. And then this one here, I can see that it's 2 up from this point at the bottom, and it's 1 space to the right. So 2 up and 1 space to the right. Again, you might have counted, so I can already see, look, I've done that wrong. I've gone 3 spaces up. 1, 2, 3, 4, 5, 6, 7, 8. So there we go. It needs to go there. So I made an error there. So it's always good to double check. And once you've got your points in, join them up very, very carefully with a ruler. Okay, then we join the vertices up. Now this is not perfect. It's very hard of a digital tool to create what you can do with a ruler and a pencil. So this, for example, is slightly out, but I can't get my tool to get it over on the computer. On paper though, you make sure that your lines are as close to that vertice as possible, because your examiners can zoom in on a digital screen and the computer can measure any errors, and you only get the tiniest amount of error allowed to get that mark. And this is a 1 mark question, so you've got to be very, very careful that you do this all very accurately. Question 9. Write the missing numbers in the table. So number of weeks, number of days. So we know that there are 7 days in a week. So as the weeks go up in 1, the number of days goes up in 7, but this is actually not going up in ones, 1, 2, 4, 6, 10. So what we need to think about, this ratio really, is we're multiplying by 7. This column multiplied by 7 makes this column. So for this one, we're simply doing 6 times 7. So you're doing your 7 times tables. This one, 10 weeks times 7 is 70. And if we're timesing by 7 that way, that means we're dividing by 7 that way. And here we've got 105. If you're not sure of how to do that mentally, like using chunking, you can just do a little bus stop. 105 divided by 7. 7 into 1 doesn't go. 7 into 10 goes 1 with a remainder of 3. And 7 into 35 goes 5. It is 15. Question 10. What is the perimeter of the shape in millimeters? Use a ruler. It's in bold millimeters, so that means that that's an important piece of information, and we need to use a ruler. And the second part of the question is to measure the size of angle D. Use an angle measurer, so you would need to use a protractor there. So I'm going to quickly measure this shape here for the perimeter. So for this question, you need to use a ruler, you need to measure around each side, and you need to make sure that you use the millimeter part of your ruler, not the centimeter part. So the millimeter part is the smaller increments in between the centimeters. So 1 centimeter should have 10 little lines that show your millimeters. Now my printout of this may be slightly different to the actual test paper. So there may be a bit of inaccuracy, and yeah, so I have labelled each side. You can see here I've labelled 34mm, here 34 millimeters, here 72 millimeters, and here 63 millimeters. So you just measure around the sides, you write in your millimeters, and then you add them up. So I've written on here, I've added them up. I've added my two 34s up to be 68, and then I've just simply added them up. So my answer I've come up with is 203, and in fact that was the lower end of the boundary of numbers that was included. Anything between 202 and 218 would have been acceptable for this answer. Okay, so let's look at the second part of this question. For this, we need to use a protractor. I'm going to use an online protractor to show you how to solve this problem. Okay, so once you've identified which side of the protractor to use, so if you look at the protractor, there's a left and a right side of that semicircle. Our angle is going to the left. so it needs to be in that left side of the protractor, and I need to make sure that the vertices lines up nice and neatly in the corner, and that the baseline also lines up nice and neatly. Now if I go along the baseline, you'll see there's 2 lines of measurement. I need to go to where it is 0 and then count around there till I get to that line. So this line's here. You can see it's just above 55 in mine. Could be 55 or 56. It's a lot harder to be accurate using this sort of digital tool, and this is obviously not a proper printout, but I would be putting 56 millimeters in for my answer for this. And the actual answer that's acceptable is anything between 53 and 57. So from 53 up to 57 included, you would have got a mark for this. Question 11, write the missing digits to make this subtraction correct. Okay, so in bold subtraction, make sure you pay attention to the fact that it is a subtraction. Okay, here we have something subtract 5 is 8. So we can work backwards. 8 plus 5 is 13. Now we obviously can't write 13 in this box, but we can write the 3. And then what we know is that if we were subtracting, we would do 3 take away 5. We can't do it, so we would have had to have done this. Okay, so actually start to calculate it. So now we know 6 subtract something is 6. Now if you had left that a 7, you would have put a 1 there, but in fact it's a 0. 6 subtract 0 is 6, and 5 subtract 3 is 2. And then if you want to, just double check it. 573 take away 305. 3 take away 5 we can't do. 13 take away 5 is 8. 6 take away nothing is 6. And 5 take away 3 is 2. And then you can see that it is correct. So it is about, this bit's the trickiest bit. It is about working backwards and just applying everything you know about subtraction. Here are 4 fractions. Write the fractions in order, starting with the least. Okay, so you can see that all these fractions have different denominators, so we might need to do a bit of finding the equivalents to help us with this. So I can see that my 8 and my 4, I can make those both equivalent, and my 5 and my 10, I can make those both equivalent. So my 1/5, I'm going to make that into 2/10, so I can compare that with my 8/10, and my 3/4, I'm going to compare that with my 7/8 by putting 6/8. That gives me a bit more help. Now we can use a little bit of common sense. 1/5 is clearly the smallest fraction. 8/10, the numerator, and the very close to the denominators, and 7/8, 3/4 and 8/10, they're quite big fractions. So my 1/5 is definitely the smallest. And remember to write it in how it's represented in the question. Don't write it in the equivalent form that you may have used to help you. I'm just going to zoom in. Now I know that my 6/8 definitely comes before my 7/8, but we don't know where the 8/10 fits in. So does it fit in there, or does it fit in there? So we can now find another equivalent fraction. So 8 and 10, the smallest equivalent denominator is going to be 40. So if I change my 8/10 to 40, that's going to be timesing it by 4, so that is the same as 32 over 40. 7/8, so that's going to have to be times by 5, that would be the same as 35 over 40, and 6 over 8 would timesing by 5 would be the same as 30 over 40. So you can see your 32 over 40 goes in the middle. So therefore 8/10 goes in the middle. So we can write that in now. 6/8, 8/10, and then 7/8. Question 13. There are 20 boxes on a truck. The boxes are in 4 different sizes. And you can see there's a diagram here with the different sizes, and it tells you the quantity of each box as well. What is the total mass of the 20 boxes on the truck? So for this, we're going to have to calculate the amount, what each size, the total of each size of box. So if we started with this, we're going to have to do 4 lots of 6.5. Then we've got 8 lots of 4. We've got 6 lots of 2.5. And we've got 2 lots of 13. Okay, so let's do the ones you can definitely do mentally. 8 times 4, so that's 32. 2 times 13, that's 26. Now we can look at the decimal ones. Now you might want to write it out in a short multiplication. I would just do 4 lots of 6 is 24, and 4 lots of a half, or half of 4, is 2. So 24 plus 2 is 26. You can just partition your whole number and your decimal number. I've done some examples of this in this year's arithmetic paper, doing a multiplication where you've got a mixed number, a whole number, and a part of a number. 6 times 2 and a half, well 6 times 2 is 12, 6 times a half, or half of 6, is 3. So 12 plus 3 is 15. So you've got how much each of those boxes, each group of those boxes weigh, and now you just have to add it up. So I would add it up here. 6 plus 2 plus 5 plus 6. So 6 and 6 is 12, plus the 7 is 19. And 2 plus 3, 5, 6, 8 and 9, 99. I've just added those up. So your final answer is 99 kilograms. Question 14. Look at the data in this table. So we've got label, and we've got letters and percentages. Using this data, draw 2 lines and write 3 labels to complete this pie chart. So we've got A and B, we need to put in C, D and E. This is actually quite a relatively simple pie chart question from what there could be really. It says A is 20%, and you can see it's taken up 2 segments. So that's given us already the clue that these segments are worth 10%. And if you count round 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 segments in there. So we know that, so that's nice and easy. So A's taken up 2 sections, 20%. B's taken up 2.5 sections, 25%. C needs 15. Now you've got this bit here already done for you, because that's 5. So you just need this whole section here, which is 10, and this half section, which is already drawn for you. So I've just put it in red so that you can clearly see what I've put in. So the 5 was already done, and we've just added on, we've got a whole section and a half section. That makes our 15%. We just now need to label that as C. Okay, D was 30%, so we're just going to need to have 3 whole sections, 1, 2, 3. So we're going to put our line here, and then label that D, and then we just need to check that's left us with a gap of 10%, which is correct. E is 10%. So that's it. We just drew 2 lines in and labelled our sections. That's all we need to do. Question 15. 35% of the 680 pupils at a school have a pet dog. 159 of the pupils who have a pet dog are boys. How many of the pupils who have a pet dog are girls? So it's very important you pay attention to this question. We're here 159 of the pupils who have a pet dog. So we don't know how many pupils have a pet dog, so we need to calculate that bit first. And it's 35% of the 680 pupils have a pet dog. So the first thing we need to do is to calculate 35% of 680. So to find the 35%, I am going to find 10% is 68. So 30% will be 3 lots of 68. So you might need to do a separate calculation. 3 8s are 24. 6 times 3 is 18 plus 2 is 20. So 204 is 30%. 5% is just going to be half of that 10%. Half of 68 is 34. Now I'm going to write it like this under my 30%, because then I can add this up. It's only this bit I need. So 4 plus 4 is 8. 0 plus 3 is 3, and 2 plus nothing is 2. So I know that there are 238 pupils, so 159 of the pupils who have a pet dog. So 159 of the 238 are dog. How many of the pupils who have a pet dog are girls? We're just going to find the difference. If there's 159 are boys, then the rest are girls. So we'll do a simple subtraction. So we'll now do 238 subtract 159 to find the difference. 8 subtract 9 we can't do. 18 subtract 9 is 9. 2 subtract 5 we can't do. 12 subtract 5 is 7, and 1 subtract 1 is nothing. So the difference is 79. So 79 girls own a pet dog. Write a number in the box to make this correct. 3/5 is less than a number over 100, and it's less than 0.7. Now to do this, the best thing to do would be to make everything over 100. So 0.7 is 7/10, which means it's 70 over 100, and 3/5 is 6/10, which means it's 60 over 100. So this number here can be anything between 60 and 70. 61 would work, or 69 would work. I'm just going to go right in the middle and put 65 over 100, but any number from 61 to 69 would be correct here. Tick the numbers that are factors of both 54 and 72. Now first of all, I can see these are both even numbers, so I know that 2 will definitely be a factor of both. Next I would actually go to the largest number and then start working down, because these numbers are in the times tables that you would have learned. You know, the first 12 multiples is what we normally learn in our times tables. So 54 is in the 9 times table, and so is 72. If we go to 8, 72 is in the 8 times table, but 54 isn't, because we've got 48 and 56 are the multiples, so it's not in that one. 4, now you might want to do a bus stop, or you could do a bit of chunking. So for example, I know that 4 times 12 is 48, and 54 is 6 times bigger, so 54 is not in the 4 times tables. Now for 3, you might want to, we know that it's in the 9 times table, so if it's in the 9 times table, 3 is a factor of 9. If it's in the 9 times table, it is also going to be in the 3 times table. If you want to double check, then you can just do 54 divided by 3, and 72 divided by 3. And you can see it is, but if it's in the 9 times table, because 3 is part of the 9 times table, it's also going to be in the 3 times table. That doesn't work the other way around, by the way, but it works this way round. Layla wants to buy a camera that costs £65. For the first 10 weeks, she saves £2 each week. Then she saves £3 each week. How many weeks altogether does it take Layla to save £65? Okay, so we know we need to get to £65. And we've got this information here. For the first 10 weeks, she saves £2 each. So we can do a simple calculation there. We're just doing 10 weeks times by £2 is £20. And then we know that if we do 65, subtract that 20, she's got £45 left to save. And then she saves £3 each week. How many weeks altogether? So we need to find out how many 3s fit into 45. So 45, you might do it mentally, or you might do it in a bus stop. 3 into 4 goes once, a remainder of 1, and 3 into 15 goes 5. So it takes her another 15 weeks. Don't forget to take account of this, how many weeks altogether. So there was 10 weeks of £2, and then 15 weeks of £3. So you've got your 10 weeks plus your 15 weeks. Don't forget to do that, which in total gets you to 25 weeks. So always make sure that you take account of everything in the question, and just double check the final question, what actually answer of my calculating is it asking for. Complete this division. So we have a division with part of our answer, and we just need to complete it. So what we're going to do is we are going to start from the beginning and imagine that we did have the answers to this. I'm going to zoom in. So we can see 12 into 4 doesn't go, there's a gap here, so we're looking at 12 into 43. So just calculate that. How many times does 12 fit into 43? Well, it fits in 3 times. That's 36. Now, I would do this as a long division, so we're going to write 36 underneath, subtract it, and then that's 7. And then the next bit would be 76. Doesn't matter if you didn't do it as long division. If you did it as short division, you would have just put your 7 there. You've still got 76. So the next part is how many times does 12 go into 76? Yeah, it goes in 6 times. I would show that underneath here. 12 times 6 is 72. Subtract that, we've got 4. So something in this box would produce a 4 with a remainder of 1. So 12 times 4 plus 1 would make this number. So it's going to be 49. Okay, so that means that's a 9. So 12 into 49 goes 4 times, because that's 48, with a remainder of 1. So what I did was we've multiplied the divisor by this to get this. Yeah, this divided by this makes that, so that times that makes this. So it's just knowing the inverse of multiplying and dividing. So I knew that a number here, 40 something divided by 12 was 4 with a remainder of 1. So I just needed to do 12 times 4 plus the extra 1 to get my answer. If you need to, if you're not sure, if you think, oh, I don't know if that's definitely right, just write it out again and then do the calculation, and then you will soon see that it will come up with the right answer. Here are 4 shapes on a grid. Write the letters of all the shapes that have only 2 acute angles. Very important, this is in bold, only 2 acute angles. So make sure if there's one with more than 2 acute angles, it's not being counted. So let's zoom in and let's identify our acute angles. In shape A, these are all 3 acute angles. So that does not count because it's only 2. In shape B, that's an acute, that's an acute. With a trapeziums, we have a pair of acute and a pair of obtuse. So it's knowing a little bit about your shape properties, just knowing them, but also you can identify it from the drawing. This triangle, we've got a right angle here, that is acute, that is acute. And in this triangle here, this is an obtuse angle at the top, but this is acute, and that is acute. So now we can see the ones with 2 acute angles are actually all of them except for A. So we've got B, C, and D. Just to note, it wouldn't matter if you wrote D, B, C. It doesn't matter about being alphabetical as long as you have written all of the shapes that have only 2 acute angles. Question 21. A band holds a concert for charity. The tickets cost £27 each. They sell 635 tickets. They pay £3,180 to use the hall. They give 1/3 of the remaining amount to charity. Remaining is in bold, so we need to take account of that. That means after they've paid the £3,180 from the ticket sales, what is remaining, they calculate 1/3 of it. How much money does the band give to charity? So let's start from the beginning. The tickets cost £27 and they sell 635 tickets. So this is the bit we need to calculate first. So we are calculating the cost of these tickets. We're going to write the 635 first, write the bigger number on top in multiplications, and times that by 27. So just a long multiplication. I'm just changing up my answer box here for long multiplication. So 5 times 7 is 35. 3 times 7 is 21, plus the 3 is 24. 6 times 7 is 42, plus the 2 is 44. Use our placeholder. 5 times 2 is 10. 3 times 2 is 6, plus the 1 is 7. 6 times 2 is 12. And then we add up. So 5, 4, 11, 7 and 1. So the ticket sales, we get £17,145 from ticket sales. It then says they pay £3,180 to use the hall. So that's going to be deducted. So we're going to do a subtraction. 17,145 subtract 3,180. So 5 subtract 0 is 5. 4 subtract 8 we can't do. 14 take away 8 is 6. 0 take away 1 we can't do. 10 take away 1 is 9. 6 take away 3 is 3. And 1 take away nothing is 1. So after we have paid 3,180, we've now got 13,965 left. They give 1/3 of the remaining amount to charities. The remaining amount is 13,965. We need to find, it says how much money does the band give to charity. It's not asking for how much money we got left after we've given to charity, so we're finding 1/3 of that amount. So we can do this as a simple division. To find 1/3, you divide by the denominator. So we're just going to do 13,965 divided by 3 in a bus stop. So 3 into 1 doesn't go, 3 into 13 goes 4 times with a remainder of 1. I'm just doing this as short division because 3 is a very simple multiple to do in your head. 3 into 19 goes 6 times, 6 times 3 is 18, there's a remainder of 1. 3 into 16 goes 5 times, 3 times 5 is 15, there's a remainder of 1, and 3 into 15 goes 5 times. So 1/3 of 13,965 is 4,655, and that is what the question is asking. How much money does the band give to charity? So it is this amount, the £4,655. Question 22. Sarah makes jewellery using black and white beads. She shows this rule to work out how many black beads to use. Black equals white times 3 plus 4. So this is an algebraic expression. Sarah uses 12 white beads to make a necklace. How many black beads does she use? 1 mark. And in the second part of the question, Sarah uses 25 black beads to make a bracelet. How many white beads does she use? So we're just going to do a bit of substitution. That is, we're going to take the information and replace the formula with the information we've got. So black equals white times 3. We know we've got 12 white, so instead of white times 3 we would put 12 times 3 plus 4, and that's going to give us our black. So 12 times 3 is 36 plus 4 is 40. Okay, we've just replaced the algebra, the unknown variables in the expression, with the information we've been given. So in this one, Sarah uses 25 black beads to make a bracelet. We've got the black part of the formula. So in this one we would write 25 equals W times 3, or you could write white if you want in brackets, plus 4. Okay, so if 25 is this unknown number plus 4, then we can take that 4 away, and we would know that 21, if we took those 4 beads away, we would just be left with the white beads times 3. So now we've got something we can use the inverse of. I'm just going to write it up here. If I said to you W times 3 equals 21, if I wrote it that way round, hopefully you can see the inverse. To do the inverse of times by 3, we divide by 3. So that means that 21 divided by 3 will give us the number of white beads, and 21 divided by 3 is 7. And then just check it. So the number of black beads is white times 3 plus 4. So if we had 7 white beads times 3, that's 21. Add the 4 is 25, and she uses 25 black beads. So we know that we are correct. Question 23, complete the table. Name a 3D shape, and we've got cube, pentagonal, prism, triangular base pyramid, and number of faces. So this question does involve you having an understanding of the property of 3D shapes. So we're looking at the number of faces. So for a cube, we know that each face is a square. So you might even want to sort of draw that on there if it helps you to remember. So you know a cube goes like that. So it's got one face at the front, one face at the back, and then it's going to have a face for each of these sides. So four faces around the edge of the square, and then front and back. That makes 6. A pentagonal prism. So if I just drew a pentagon, not very good pentagon, but it's got 5 sides. A pentagonal prism. Prisms have face at either end, so 2 faces, and then they have a face for each one of its sides. A pentagonal has 5 sides, so there's 5 faces around the outside, a bit like the cube, and then 1 on each end, so that's 7. And a triangular base pyramid, So it's got triangle base, so that's 3 faces are going to rise up from this base, but then the base is also a face. So this is one face, and then you've got the face coming up from there, the face coming up from there, and the face coming up from the front. It's a bit hard to draw a triangular base pyramid, but you've got 3 sides, where the 3 walls, you can imagine the base and then 3 walls. The walls come from the base of the pyramid, and then you've also got the base as well. So that is 4 faces. Question 24. 1/2 times 5/6 is greater than the value of 1/3 times 7/8. Explain how you know. So for this, I would simply calculate both of them and then see where you are there. So I'd first of all calculate the first one, 1/2 times 5/6. Multiplying fractions, you just multiply the top and then multiply the bottom. And then, so 1/2 times 5/6 is 5/12, and move over. 1/3 times 7/8 is 1 times 7 is 7, 3 times 8 is 24. So now you can see we've got 5/12 and 70 and 7/24s, so we can compare these because 12 is a factor of 24, so we can change this 5/12. 5/12 is equal to 10/24, and we can just say full stop, 10/24 is greater than 7/24, or you might even just write right down here, you might write 10/24 is greater than 7/24. Means the same thing written mathematically.